Alright, this is Mr. Gillum, and today we're going to learn how to factor the greatest common factor. Again, in fact, it's something we've already talked about, except for now we're going to have some algebraic expressions as well. And we'll see if my computer's up to speed today or not really fast. Alright, the distributive property. We've talked about this a little in the past. The distributive property, The distributive property basically says this. There is an operation in between a number and the parentheses that's not written there, but is present. It's a multiplication sign. So whenever something is really squished up against something else, it's held together with a multiplication sign. All right, and the distributive property says whatever that number is, that number doesn't just get multiplied by one thing, it's multiplied by everything inside the parentheses. But now we're adding a variable. So before, it might have just said 3 times 2 plus 5. Now, instead of a 5, it's a 5a. So the distributive property says 3 times 2 is 6, and 3 times 5a is 15a. Similar to what we learned when we were talking about multiples of a sum. 2 times 1 is 2, 2 times 2b is 4b. 5 times 3c is 15c, and 5 times 7 is 35. 4 times 6d is 24d, and 4 times 1 is 4. All right, so this is a property that we practiced just a little bit when we were talking about multiples of a sum. And what we're only adding now is the variable. Okay, and notice when I multiply the 3 times the 5a, the exponent on the a doesn't change. It's just the coefficient in front of a that we're multiplying. Okay, so instead of having 5a, we have 3 5a's or 15a's. Instead of having just a 2b, we have 2 2b's or 4b. 5 times 3c is 5 3c's or 15c's total. And 4 6d's would make 24d's. Okay, if that makes sense. Hopefully it does. So that's how the distributive property works, but it also works backwards as well. And so this goes back to when we learned about the greatest common factor. When I look at 6 and 15, or I should say 6 and 15a, they are not what we call like terms. Okay, 6 is called a constant, and 15a is a variable term. And so we can't just squish it all together and make it 21a, because 6 is talking about numbers, and 15 is talking about animals or something else. So we can't just squish it all together. They're different. They're not like terms. But what we do notice is that 6 and 15 has a greatest common factor of 3. So what I'm going to do, just like when we talked about multiple of the sums, is I'm going to take that 3 on the outside, the greatest common factor. So this number in front is the GCF, and it must be the greatest common factor. So if you need to make a factor tree, that would be fine too. If you notice that numbers inside still have something in common, I'll show you an example of that in a second. That means you didn't take out the greatest common factor. I know 3 times 2 would equal 6, and I know 3 times 5a would equal 15a if I did the distributive property again. So that's how I would factor 6 plus 15a. All right. 2 plus 4b. I know that 2 and 4 are both even numbers, so 2 must go into both 2 and 4b. 2 times 1 would equal 2. 2 times 2b would equal 4b. 15c and 35. Well, they both end in a 5, so I know they must both be divisible by 5. So I'm going to take the 5 on the outside, and I know that 5 times 3c would equal 15c, and 5 times 7 would equal 35. All right, now I want to show you an example of one if I didn't take the greatest common factor out. Let's just say I didn't notice that 4 was the greatest common factor, and I just thought, oh, they're both even numbers, 2 must be the greatest common factor. If I take the 2 outside, I know that 2 times 12d would equal 24d, and 2 times 2 would equal 4. So what I'm going to do instead is what I notice between 12 and 2 is there's still a number that they share. That just means that this was not the GCF. And when we're factoring, we always want this number to be the GCF. So what I do notice about 12 and 2 is that they still share a 2 in common. So I could take another 2 outside. And remember, this is held together with multiplication. So instead of saying 2 times 12d plus 2, let's take another 2 out of this term. So now I have a 2 on the outside already, times another 2 on the outside, and instead of 12d plus 2, I know 2 times 6d would equal 12d, and I know 2 times 1 would equal 2. Again, this 2 is the same as this 2, and I'm factoring again into all of this. But now, of course, 2 times 2 is 4 times 60 plus 1. So that's a little strategy you can use if you didn't take the greatest common factor out the first time. You can just factor whatever's in the parentheses again and multiply it by whatever you thought the greatest common factor was in the first place. Of course, if you pick the greatest common factor right off the bat, you can always go straight from 24d plus 4 to 4 times 6d plus 1. All right, and so now we're incorporating a little bit of algebra. We have some variable expressions that we're factoring. We called it a multiple of a sum before, and now we're going to call it factoring. Okay, we're finding the greatest common factor, and we're using the distributive property to take it outside of the parentheses. So again, I just want to stress the distributive property can go forwards or it can go backwards. But when you're going backwards, it's always the greatest common factor that you want to take outside the parentheses. It's all held together by multiplication. Just remember that. There's a multiplication sign in front in there that isn't written, but it's there. Okay? So that's it for today. It's called factoring the greatest common factor.